There was a moment in March 2020 when something happened in kitchens all over the world that nobody had planned for. The shelves emptied. First it was toilet paper, then it was rice, then flour, and then suddenly, almost overnight, the small foil packets of yeast that had been sitting in the same aisle for decades simply vanished. Stores ran out. Online sellers ran out. Bakers who had been baking their whole lives stood in their kitchens with bags of flour on the counter, water in the tap, time on their hands for the first time in years, and no way to make bread rise. And the strangest part of that whole moment was not the empty shelf. The strangest part was the silence that followed when people realized they had no idea how to fix it. Because for thousands of years, nobody waited for a packet to arrive. Nobody checked an expiration date. Nobody drove to a store to ask if a shipment had come in. Bread was made because somebody in the household kept a jar alive on the counter, and that jar held a culture that had been passed from one batch to the next for as long as anyone could remember. Some of those cultures, the ones that survived migrations and wars and shortages, are still alive today. There is a famous one in San Francisco that has been working continuously since the 19th century. It has never once needed a supermarket. It has never once been replaced. And during that week in March 2020, the people who had something like it on their counter did not panic because they were not waiting for anything to arrive. What I want to share with you today is the method that quietly saved a lot of those people during that month, and the method that has been saving households for centuries before any of us were born. It is built on a potato, water, and 3 days of patience. That is the entire shopping list. And by the end of this, you will understand not just how to do it, but why this small jar represents something much larger than bread. Let me first explain what is actually happening when you make commercial bread, because this is the part most people were never told. The yeast you buy in those packets is a single strain. One species. It was selected and cultivated under sterile industrial conditions for one job. And that job is to produce carbon dioxide as fast as possible so that dough rises in the shortest amount of time. That is what the bakery industry needed at the end of the 19th century, when speed and predictability became more valuable than tradition. And it works. The bread rises. The loaf comes out of the oven. From the outside, everything looks correct. But inside that wheat grain, something never finished. There is a compound called phytic acid that lives naturally in all grains. It exists as a defense, a way for the seed to protect itself in storage. The problem is that when you eat phytic acid in bread, it binds to minerals in your digestive tract, iron, magnesium, zinc, calcium, and it carries them out of your body before you can absorb them. So you eat the bread, you feel full, you think you have nourished yourself, and a portion of what should have stayed in you simply leaves. That is the quiet difference between feeling satisfied and actually being fed. Slow fermentation changes that completely. When wild yeast and the lactic acid bacteria that live alongside it work on dough for many hours, they release enzymes that break down phytic acid. The minerals become available. Your body can finally reach them. And the same process also breaks down a significant portion of the gluten and the complex carbohydrates, which is why traditionally fermented bread is easier on the stomach and produces a slower, gentler rise in blood sugar. None of this is folklore. Researchers have measured these differences in clinical settings. The bread is not just different in flavor. It is different in how your body receives it, and that is worth pausing on, because it explains something most of us have noticed without naming. How many people do you know who say bread does not sit well with them anymore? Bloating, heaviness, that uncomfortable feeling an hour after a sandwich. 2 generations ago, that was not a common complaint. The wheat is largely the same. What changed was the fermentation. What got removed was the slow biological work that for 10,000 years made bread digestible for the human stomach. What replaced it was a 90-minute industrial process that skipped every single step that mattered to your gut. Now we get to the practical part, because all of this matters very little if you cannot actually make it at home. Wild yeast is in the air around you right now. It is on your countertops. It is on the skin of fruit. It is sleeping in any flour that has not been irradiated. The trick is not to capture it from somewhere exotic. The trick is to give it an environment so welcoming that it wakes up, multiplies fast, and pushes everything else out before any harmful microbes can get a foothold. And of all the substrates that humans have used over the centuries to create that environment, potato water has earned its reputation honestly. A potato is mostly amylopectin starch. When you boil it, that starch gelatinizes and seeps into the cooking water, and what you are left with is a warm, slightly sweet liquid filled with complex carbohydrates and minerals that wild yeast loves. Potato water feeds a young culture more steadily than sugar alone. It also slows down the buildup of acid that can kill a fragile culture in its first days, before the colony has had time to establish itself. So you are not just trapping yeast from the air. You are giving it a stable beginning, the right food, and the right pace. There is a baking textbook published in Boston in 1884 that already documented this. The author wrote that potato yeast rose faster and kept longer without souring than other handmade cultures of the time. A century of food science has confirmed the same thing, and the bread it produces does not taste like classic sourdough. That surprises people the first time they try it. Sourdough has that sharp, tangy edge that comes from heavy bacterial activity in flour-based starters. A potato water culture develops with much less of that bacterial dominance. The result smells slightly sweet and yeasty rather than acidic, and the bread that comes out has body and complexity without the sour finish. It tastes closer to what European bread was like before factories standardized everything. Here is exactly how you make it. Take a large potato and peel it. The skin matters because conventional potato skins can carry pesticide residues that interfere with yeast development, and you want a clean substrate. Boil the peeled potato in enough water to cover it generously and let it cook until it is completely soft. That usually takes about 30 to 40 minutes depending on the size. Test the center with a fork. If you feel any resistance, keep going. An undercooked potato leaves raw starch behind, and raw starch feeds the wrong organisms. When the potato is fully soft, take it out and pour the cooking water into a clean glass jar. Let it cool until it is warm to the touch but no longer hot. This is the step almost everyone rushes, and it is the most common reason cultures fail. Hot liquid kills yeast instantly. You cannot save time here. Wait for it to drop to a comfortable warmth, the kind you could keep your finger in without flinching. Then mash the potato and add it back into the jar with the cooled water. That mashed potato at the bottom of the jar gives the developing colony a concentrated starch base to feed on while it gets established. Cover the jar with a clean cloth or a paper towel held in place with a rubber band. Do not use a lid. The culture needs to breathe, and it also needs to release the small amounts of carbon dioxide it will produce. Place it in a warm spot away from direct sunlight. A kitchen counter usually works, as long as it is not next to a cold window or directly above a hot stove. Within 24 to 48 hours, you should start seeing small bubbles forming on the surface. That is the yeast waking up. After 2 to 3 days of clear visible activity, with bubbles, a slightly sweet and yeasty smell, and gentle movement in the liquid, the culture is ready to bake with. At this stage, you are not looking for industrial perfection. You are looking for signs of life. Once you can recognize those signs, the whole process stops feeling uncertain and starts feeling like reading a familiar handwriting. To use it, pour off the starchy liquid from the top and use it in place of the water in any bread recipe. A reasonable starting point is around 240 milliliters of active potato culture liquid for every 360 grams of flour. But this is a starting point, not a strict rule. Wild yeast is not as concentrated as lab-cultivated yeast, and every culture is a little different. A vigorous, bubbly culture can carry more flour. A younger or quieter one will need a slightly higher ratio of culture to flour. When in doubt, use a little more culture rather than less. And then, watch the dough. That is the part that takes some getting used to. With industrial yeast, you set a timer. With a living culture, you read the dough. You learn what the right rise looks like, what the right smell is, how the surface should feel under your fingers. Expect the fermentation time to be 2 or 3 times longer than what you are used to. That is not a flaw. That extra time is exactly when all the health benefits we talked about earlier are being created. Phytic acid is being broken down. Gluten is being predigested. Minerals are being released. The body of flavor is developing. You are not waiting around for nothing. You are letting biology finish a job that the foil packet skipped. To keep the culture alive indefinitely, you do not start from zero each time. You boil another potato, add the cooled water and a little mashed potato to whatever is left in the jar, and within a few hours, the culture wakes back up. Between bakes, you can keep it in the refrigerator. It will go dormant, but stay stable for weeks. Take it out, let it sit on the counter for a few hours to come back to room temperature, and it returns to life. Each cycle takes a few minutes of attention. There is no daily feeding routine like a flour-based sourdough demands. There is no constant discard. You are not throwing away half a jar every morning to keep the rest from overflowing. That last point is worth its own moment, because it is one of the quiet advantages of this method. A flour-based sourdough starter has to be fed flour and water every day or two. The colony grows. You discard part of it. You feed it again. It grows again. Over time, this is fine for people who bake constantly, but it becomes a small daily obligation. The potato water culture does not work like that. You only refresh it when you are about to bake. The rest of the time, it waits patiently in the refrigerator. It does not demand anything from you between sessions. But if at any point you do find yourself with more active culture than you need before your next bake, do not pour it down the drain. Mix 2 to 4 tablespoons of flour into the leftover culture, add a pinch of salt, and let it sit for a few minutes while you heat a pan with a little oil. What you end up with is something between a thin pancake and a flatbread, with crisp edges, a slightly tangy interior, and a flavor that is hard to compare to anything from a store. Add a sliced green onion to the batter, finish with olive oil, and it could come out of a small neighborhood restaurant. The leftover is not waste. It is a second recipe waiting in the same jar. Before we close, there are 2 practical details that make the difference between a culture that thrives and a culture that quietly fails. The first is water. Always use filtered or chlorine-free water at every stage, from the boiling of the potato to the rinses you do later. Chlorine is added to municipal water specifically to suppress microbial activity, which is exactly the opposite of what you want when you are trying to grow yeast. If you only have tap water, let it sit uncovered for several hours so the chlorine can dissipate or filter it. The second detail is your nose. A healthy culture smells alive. It smells slightly sweet, faintly yeasty, maybe a little earthy. It is something you do not mind bringing close to your face. If at any point the jar smells truly rotten, like something turned wrong rather than something fermenting, do not try to save it. Pour it out, wash the jar, and start again. The cost of starting over is 1 potato and 3 days. The cost of forcing a bad culture is a ruined loaf and a kitchen that smells off for a week. There is no need to make this more complicated than it is. If the culture shows good activity, smells right, and responds when you feed it, you are on the path. If it looks weak or smells wrong, restart. That decision tree is the entire troubleshooting guide. A jar of wild potato yeast costs you 1 potato and 3 days of patience. Once you have it, it does not expire. It does not run out. It does not come with a printed date that tells you to throw it away. It improves with time. It produces bread that is measurably more nutritious and easier to digest than anything made with an industrial packet. And it gives you something that the spring of 2020 made very clear most modern kitchens had quietly lost. Real independence from a supply chain that already proved, in front of all of us, how fragile it really is. For 10,000 years, bread was made from a living culture maintained at home. In a single century, an entire civilization was convinced that the same job needed a foil packet, a factory, an expiration date, and a recurring trip to a store. That trade was not made because the new way was better. It was made because you cannot charge someone every week for something they already have alive in a jar on their counter. Now you know how to put one back on yours. If this kind of forgotten knowledge is the kind of thing you want more of, subscribe to the channel and join us in the next one.